Welcome everyone to your virtual academic orientation tour. My name is Nikki and I'll be your virtual tour guide today. I graduated from the aerospace engineering program here at Carleton a few years ago. I now work for the Faculty of Engineering and Design's outreach team. In this tour, we'll be looking at some important spaces on campus, including some labs you can expect to see as you progress through your degree. We're now in front of the Minto case building. This is part of the main engineering building on campus and is connected to the McKenzie building, which you'll see later on. Let's head inside. In the main lobby area, if you look to your right, you can see the entrance to one of our largest lecture rooms, Bell Theater. Remember this location, as a lot of first-year students always struggle to find this theater. We'll now be moving downstairs to our environmental engineering lab. We're now in the basement of the Minto building. This lab is essentially a chemistry lab for environmental engineering students to understand the chemical, biological, and physical processes involved in cleaning air, water, and soil. Students will take river water and separate its contaminants using chemical physical processes, or treatment using UV light. Wastewater treatment is done by using microorganisms to break down the contaminants in the wastewater. The materials that settle out form a sludge that can be degraded anaerobically to produce methane and energy. Air quality is measured and analyzed using an air sample from the roof of this building. Fourth-year projects include designing systems to clean air and water, cleaning up contaminated sites, gas stations, LeBreton Flats, evaluating waste management alternatives and waste to energy, designing systems to reduce greenhouse gases, and improving air quality and conserving water. We're back on the main floor. This is the John Adeline Lab. This lab is used by second, third, and fourth year architectural conservation and sustainability engineering students, environmental engineering students, and civil engineering students. The test facility is 11 meters high and has 3,000 square feet of floor space. If you look up, you'll see a crane used to move heavy equipment around the room. This room is also equipped with a strong floor that is 1 meter thick. If you look down, you'll see circular discs that can be removed from the floor. There are approximately 600 holes in the floor to allow us to test different structures. Test beams can be secured to the floor through these openings. The foundation of this area is also separate from the rest of the building around us, so test vibrations do not impact the structure or disturb people working. MTS loading machines can perform compression and elongation analysis to samples rather than an entire structure at variable speeds, as stresses produce different results at different speeds. Tensile, compressive, and cyclic load testing is done using hydraulics wired to an Ethernet analysis, which can simulate year-long experiments in shorter times. Students will also have the opportunity to learn how to use surveying equipment and will make their own concrete beams to be used for testing shear strength. You've probably been receiving a lot of emails from our Engineering Academic Support Office, or the ASO for short. The ASO team is here to assist engineering students with course selection, registration, learning resources, and extra support. They're available to help you from your first year all the way through to graduation. All ASO services are currently being delivered remotely. We'll now be heading to the 5th floor of the Minto Case building. Here we have the Elsie McGill Learning Center, or as I'll refer to it as, the Elsie Center. We're focused on ensuring that students have an understanding and comprehension of their engineering studies, and we're here to provide some academic support to help you achieve your learning goals. The Elsie Center operates using a peer tutoring model to offer academic support to first-year engineering students. Peer tutors, who we call scholars, are hired and trained to assist you in your learning. Whether you have a quick question, you just want to review a solution, or you want an explanation of some content that was covered in your classes, our engineering scholars are here to help you with those. And while the Elsie McGill Center won't be delivering in-person services this fall, they will be available through our new online tutoring platform. We are now on the 6th floor of the Minto Case building. This lab is mainly used for third and fourth year biomedical electrical engineering students. Here, students use wireless biosignal amplifiers and electrodes to collect EMG and ECG signals and then write software to clean, analyze, and visualize the data. In one lab, students develop hardware and software systems to control a video game by flexing the muscles in their arm. Both second and third year students in the Department of Mechanical and Aerospace Engineering will use this lab to understand the fundamentals of solid mechanics. This is the Solid Mechanics Lab. In using the blue rig scene, students are able to analyze the deflection and strain in different cross-sectional area beams by adding weight to one end of the beam test section. Then, using this experimental data, students will apply the theory they've learned in class in order to determine the minimum and maximum stresses, elongation, and yield strength of the material. These labs are typically done with teaching assistants and students in groups of 2 to 4. Lab reports must be submitted at the end of the 3-hour lab period. This requires students to practice time management and preparation. It's also important to note that our laboratory technologists are always available to help with curriculum, lab assignments, and fourth-year project work. This is the Water Channel Lab. Again, this lab is used by students in both the Department of Civil and Environmental Engineering and the Department of Mechanical and Aerospace Engineering. Second, third, and fourth year students use this lab to understand aspects of aerodynamics using fluid dynamics. This channel is also used to study high angle of attack flows dominated by flow separation and rotary wake analysis. Used as dye water channel for these tests allow for accurate testing of small-scale models while producing excellent flow visualization, which helps researchers understand airflow behavior. We're now in the Department of Mechanical and Aerospace Engineering's machine shop.